We'll be looking at 1 alpha, identify basic facts about radio theory, primarily looking at transmitters. Remember, you got to get 70% on the KP pass. Hopefully, everybody is reading up on their study guide workbook in order to complete your exercise. It's best to do that. We look at our AFSC application. Remember, with the transceiver, it's a combination of a receiver and transmitter together. And the whole idea behind this is so you can either do what's called full duplex or a half duplex, depending on your needs. Let's see what we're going over for the day. We got transceiver, simplex, half duplex, full duplex, transmit, receive, relays, flow, and then, of course, software-defined radio. Let's begin with what the heck is a transceiver? Yeah, it's just nothing more than a transmitter and a receiver put together. That's all. There are some differences between them. We'll be looking at simplex, half duplex, full duplex, putting these in the different categories. First one is simplex, and I'm not familiar with your electronics. Did they ever talk about simplex to you? Okay, so
No, sir.
simplex is basically using one frequency between transmit and receive. Most of the time, your LMRs, your backpack radios, anything that's portable does that. We call that simplex. One frequency, either transmit or receive. In half duplex, this is where things get a little bit complicated. We're using two frequencies. Normally there is a repeater in place, which is using full duplex, and I'll explain that in just a minute. But it's been my experience that LMR radios, it's land mobile radios, those are the radios normally on your base that look like a brick with a antenna coming out of it. We have names for them called bricks, walkie-talkie. Don't say that too loud because people don't like the term walkie-talkie. LMR is another one. You can see these particular radios out and about, also to be included in your vehicles, and sometimes located on, let's just say, a work center. Normally that radio is what we call a half duplex because it is transmitting one frequency to hit the repeater to get further distances out of it. And of course, when it hits the repeater, it's going to take that frequency, turn it around, and send it to the distant at a different frequency. And we'll get into repeaters later on in the modules. Objectives. Half duplex, again, works like simplex. If you're transmitting, you're not receiving. Receiving, you're not transmitting. The only difference between simplex and half duplex is because you have two frequencies on half duplex versus simplex is only one. And there's reasons for it. Then we get to the full duplex. Normally these are with devices that uses two frequencies at the same time, normally about 200 megahertz apart. Full duplex is normally keyed up all the time. In other words, it's transmitting as well as receiving. Cell phones, your Wi-Fi, your repeaters, your SATCOM, your microwave are just examples, just a few examples of what's out there when it's doing two frequencies at the same time. Let's look at the TR relay that we covered earlier. This is a switch normally in your transceiver that is going to be your simplex or half duplex, and it's going to switch between the transmitter and receiver. The idea behind that is to prevent anything from crossing over into each other. First of all, the transmit relay switch controls the antenna when you're doing the signal flow. So the whole idea behind it is we keep the transmit side separate from the receive side and vice versa. That way, this is just an example, when we are receiving and we need to transmit, the moment that I press that key button on the radio, that relay is going to go from the side, flip it over to the transmit side, and now I can have control over the antenna to transmit my RF out. It's only going to go through the antenna. It's not going to go through the section. To do. Also, if you're in Simplex, normally the oscillator is used between your transmitter and receiver, pulls dual duty, but if you are in half-duplex, that oscillator is going to switch frequencies. So the moment you press that switch, not only are you controlling that transmit receive relay, but you're also controlling the oscillator. You're either going to change, well, basically you're changing frequency from the receive frequency to the transmit. When we look at the signal flow, it is the same for transmit and the same for receive. Here's your transmit section. The difference is we just basically broke it up for you. You got a transmit section, you got a receive section, and then you have what's called a common session. The common session is the power supply. When you turn it on, you're automatically going to go into receive. The transmit receive relay is connecting it to the antenna on the receive section. When you look at the oscillator, whatever the receive frequency is, that's what it's going to be generating, as well as when you finally key the radio, then that TR relay is going to click it into the transmit side, separating out the receive, and your oscillator is going to generate whatever frequency that the transmit section is. And of course, we're going to talk about duty cycle for a quick. Normally there are duty cycles for transmitters, for transceivers, because if you have a handheld radio, it depends on the battery. If you have a man-pack radio, it depends on the battery. They have duty cycles on them. It is normally in your characteristics, and you will find numbers that associate with them. Normally the first number is the lower number. I have seen it where it's a higher number, but look at it this way. Whatever the lower number is, that is transmit. In other words, if I have a 2080, the 20 means that 20% of the time I can key the radio. The rest of the time, which is 80%, I'm in receive. If I'm keying longer, it's going to deplete my battery life as well as heat up the radio and may cause problems in the very not so distant future. So what that means is as I keep it keyed, the more that I keep it keyed, it's going to generate heat, it's going to take away the battery life, and now I'm looking at a possible damage to the radio or depleting the battery strength, and now I'm going to have to carry extra batteries. And that's not always good if with a man-pack radio. When we look at software-defined radios, though, this is all controlled by software. Now, there are some components that can't be replaced by the software. But for the most part, you can take that radio, hook it up to a computer, and change its frequency, its output, its modulation type, just about everything that's in there. Or, like a network, can you make it full duplex, half duplex? Well, you can't make it full duplex on a transceiver that is half duplex or simplex, but you can do them on repeaters, or in our case, cell phones and satcoms and things like that. But normally we are the ones that are programming it in, and we will dictate what frequencies that they're going to be able to use. Normally the frequencies that we get are coming from a place called the Spectrum Manager, which goes out and takes a look at where we may deploy and gets authorizations for those frequencies that we need to put into our SATCOM or radio. Again, this is all done by software. It's so much easier to make that happen through the advent of a computer. So if you take a look at these, it can use all the way up to what I call the RF amplifier for, its whole internals. Normally a bunch of chips, look like a computer on the inside. But there are some parts that cannot be simulated with software through chip design. Anytime you need an upgrade, whether it's software or firmware, normally the manufacturer is going to provide it. And again, there are some components depending on the complexity of the radio. And again, most of the time, the RF amplifier is that component that's outside of it. Back when I was at Hill Air Force Base, we would step in on the contractor every now and then just to watch him do repairs. And the newer radios that were software driven basically had one big chip in it, and you could see where there was an RF amplifier and in some cases an audio amplifier to get to that chip. Other than that, it was nothing more than a chip on a ribbon cable going to those particular places. Pretty unique, I have to imagine there. So we've gone over transceivers, simplex, half-duplex, full duplex, transmit, receive, relay, signal flow, and software-defined radios.